Blocks A and B weigh 75 pounds each. Block D weighs 30 pounds. Use the coefficients of static friction indicated. Determine the friction between A and B and between blocks A and floor C. So we want the friction here and here. Let's draw a free body diagram of the two blocks. So there we go. So on this block we have tension there. We got 75 down, and that's pounds, so that is weight. That's mg. We got force of friction up, and we got the normal at B. Now this is force of friction here is a reaction. We don't know that it's sliding, so therefore we'll have to put that as a variable. On this one we'll have a force of friction down. We got NB down, 75, the center of gravity. Call it normal C up, and FB over. So first let's find out what T is. So this is 30 down, and so if that becomes T1, T2 is up here, so T2 equals T1 e to the mu beta. So T2 is equal to T1 is this one because it's trying to pull. Yeah, 30 is the T2 and this is T1. So we'll put the 30 here. And that equals T1 e to the mu is 0.5, and beta there is pi over 2. So T1 equals 13.7. So 13.7 right there. And so now let's look at block B. So if we sum the forces in the x direction, we get negative 13. Now that's an angle of 20 degrees. So we're going to get plus the force of friction cosine 20, component of that, minus NB sine 20. Now remember, we don't know what the force of friction is, it's a reaction, so that's our unknown. We can't just do NB times the coefficient of friction, 0.6. So let's clean that up a little bit, and we get 13.7 plus 0.342 NB equals 0.94 force of friction. And then dividing by 0.94, we get 14.6 plus 0.364 NB equals the force of friction. Now summing the forces in the y direction, we get 75 down. We get the force of friction going up, so plus force of friction sine 20, and we get NB going up, so plus NB cosine 20. because that's a 20-degree angle is right there, so it's going to be going up at 20 degrees, equals 0. And then for force of friction, let's put that whole thing right there. And we get negative 75 plus 0.3, that's the sine of 20, 0.342 times 14.6 plus 0.364 NB plus cosine of 20, 0.94 NB equals 0. And then we can solve this. The only thing left is NB, solving that directly for NB, and we get 66. So the force of friction is equal to 14.6 plus 0.364 NB, which is 66, and the force of friction is 38.6. And these are in pounds. Now, does it slip? The force of friction available is the normal, 66, times 0.6, and that is 39.6. So 39.6 is greater than 38.6, so it does not slip at B. Now let's look at the floor. So at the floor we have 150, so the available at C, force of friction available is 150 times 0.4, which is equal to 60. Now 60, if we do a free body diagram of the two blocks combined, we got 13.7 here. We also have a force of friction there. Those are only two horizontal forces on the combined block. It has available 60 down there, but it's going to only react there and get 13.7. So it doesn't slip at either spot.